Next, we can discuss a problem on normal distribution. So, you are given a random variable x which follows a normal distribution, and its mean is given as minus 3 and variance 4, and we have to find these probabilities. Okay, so we are given mean is equal to minus 3. So, mean of normal distribution is mu, which is equal to minus 3, and variance is sigma square, which is given as 4. So, what is standard deviation? Root 4, which is equal to 2. So, mean is minus 3 and standard deviation is 2. Now, we have to find the given probabilities. So, let us consider the first case. First case, probability that 1 less than or equal to x less than or equal to 2. Now we can find this probability. So as in the previous video, what we have to do? We have to standardize this. That is, we know that x is following normal distribution. And if x is following normal distribution, what we do for standardization? We will transform the variable into z so that z is equal to x minus mu by sigma, so that this will be transformed into standard normal variable. So for that, if you are subtracting mu from x and dividing by sigma, you have to do the same operation in LHS and RHS. Okay, so this will become probability of 1 less than mu, 1 minus mu divided by sigma less than or equal to x minus mu by sigma less than or equal to 2 minus mu by sigma. Now let us substitute the numerical values of mu and sigma here. Okay, so this will become probability of 1 minus mu. What is mu? Mu is minus 3. So minus of minus, this will become plus 3. Okay, divided by sigma is 2. Less than or equal to, what is this? X minus mu by sigma, which is z. Z less than or equal to 2 minus 3, that is 2 plus 3, divided by, what is sigma? Sigma is 2. So this will become probability of 1 plus 3, 4, 4 by 2, 2. 2 less than or equal to z less than or equal to, what is 2 plus 3? 5. 5 divided by 2. 5 by 2 is 2.5. Okay, so we have to find the probability from 2 to 2.5. Now, our normal curve is symmetric about its mean. Now we are having standard normal distribution. So standard normal curve will be symmetric about its mean. So its mean is what? 0. Okay, we have already see that z follows normal 0, 1. That means z is having standard normal distribution. That means z is a normal distribution with a mean 0 and standard deviation 1. And normal distribution is symmetric about mean. So standard normal distribution is symmetric about 0. And where will this 2 will come? 2 will be here and 2.5 will be here. And we have to find the area between 2 and 2.5. Okay, so this is the situation. Now this is our standard normal distribution table. So here you are given the area from 0 to z. So from 0 to z, that is, if you are given or if you want to find the probability from 0 to z, then you can refer standard normal table and find the value. If z is equal to 1, then probability will be, you can just simply what, 1.00, which is 0.3413. And if you want to find the probability from 0 to 1.5, this will be 1.50 this. And if you want to find out the probability from 0 to 1.58, it will be 1.58. So this is how we are going to refer standard normal table. Now in the problem we have to find the probability from 2 to 2.5. So how we can find that? We are having the probability curve or the area under the probability curve from 0 to z in the table, isn't it? So how we can find that? We can find probability from 0 to 2.5, and also we can find the probability from 0 to 2. So from this probability, if we if we subtract the probability from 0 to 2, we will get the answer. Now we can refer the standard normal table and find what is the value. Okay, so this is the standard normal table, and probability from 0 to 2.5 is 0.4938. So we can substitute the value here, 0.4938 minus, that is, we have find out the probability from here to here, that is 0.4938. Now we can find the probability from 0 to 2. What is the probability from 0 to 2? 0.4772. So we can substitute that here, 0.4772. So subtracting this, you will get the answer. So the answer is 0.0166. Okay. Now let us see the second problem. What is the second problem? Probability of x greater than minus 1.5. So in a similar way, first of all we can standardize this. So probability of, okay, I will write here, probability of x minus mu by sigma greater than minus 1.5 minus mu by sigma. That is probability of z greater than minus 1.5 minus, because x minus mu by sigma is z. Okay, minus 1.5 minus, what is our mu? Mu is 1 minus 3. So this will become plus 3 divided by, what is sigma? Sigma is 2. Now what is minus 1.5 plus 3, which is positive 1.5. So which is equal to probability of z greater than 1.5 by 2. 1.5 by 2 is 0.75. Now how we can find this area? We can draw the standard normal curve, and if this is the area, that is 0.75 comes here, we have to find the probability that the value of z lies where after 0.75, that is z is greater than 0.75. So z greater than 0.75 means the area will be this. Okay, so we have to find the probability from 0.75 to infinity. So how we can find that? Because we are having the value of probability from 0 to z in the table. So what we can do? We know that probability from 0 to infinity is 0.5. We have already discussed that in the properties, that is normal curve is symmetric about mean, and probability from minus infinity to mean and from mean to infinity is 0.5. So here mean is 0. So probability from minus infinity to 0 is 0.5 and 0 to infinity is 0.5. So this is 0.5, and we can find the probability from 0 to 0.75 from the table. So if we subtract that probability from 0.5, we will get the answer. So this is equal to 0.5 minus, then we can find probability from 0 to 0.75 from the table. So what is the probability of 0.75? 0.7 comes here and 5 comes here. So value is 0.2734. So 0.2734. So subtracting this, we will be obtaining the value 0.2266. Now what is our next problem? Probability of x less than minus 3. So let us see what is that. So probability of x less than minus 3. So which is equal to probability of, we can standardize this, x minus mu by sigma less than minus 3 minus mu divided by sigma. Okay. Now what probability of x minus mu by sigma is said? Less than minus 3 minus, what is mu? Mu is minus 3. So minus of minus plus. So this will become minus 3 plus 3 divided by sigma is 2. Minus 3 plus 3 is 0, right? So this will become probability of set less than 0. What is this probability? Probability of set less than 0 means, if this is the normal, standard normal curve, probability of set less than 0 means this whole area. That is, we have to write the probability from minus infinity to 0. So we have already seen that probability from minus infinity to 0 is 0.5 and probability from 0 to infinity is again 0.5. So the answer is 0.5. Now our fourth section. What is fourth section? Probability of modulus x plus 3 less than 2. So probability of modulus x plus 3 less than 2. So we can write this as probability of minus 2 less than x plus 3 less than 2. Okay, modulus can be written like this. So which is equal to probability of minus 2. So plus 3 will come to this side and also this side. So this will become minus 2 minus 3 less than x less than 2. Or otherwise we can say that, what is this? This is x minus mu, right? Because mu is minus 3. So minus of minus is plus. So there is no need to do this. We have to just divide this by sigma. Reason is that we have mu as minus 3. So x minus mu is x minus minus 3, that is x plus 3. So this is itself x minus mu. So when you divide this, this will be standardized. So this will be probability of minus 2 divided by sigma is 2 less than x plus 3 divided by sigma less than 2 by 2. That is probability of minus 1 less than z less than 1. How we can find this probability? Probability from minus 1 to plus 1. If we draw the graph, and if this is minus 1 and if this is plus 1, area from minus 1 to 0 and area from 0 to 1 are the same. Okay, area from minus 1 to 0 and 0 to 1 are the same. So we can write this as 2 times probability of 0 less than z less than 1, right? Because probability from minus 1 to 0 and 0 to 1 are the same. So which is equal to 2 into, now let's see what is the probability from 0 to 1 in the table. So probability from 0 to 1 is 0.3413. So we can substitute that 2 into 0.3413. So final answer is 0.6826. And we are having the last section, that is the fifth question, which is probability of modulus x plus 5 greater than 1. We can write this as 1 minus probability of modulus x plus 5 less than 1, isn't it? That is 1 minus probability of what? This can be written as minus 1 less than x plus 5 less than 1, which is equal to 1 minus probability of what we can do? We can write this as x plus 3 plus 2, so that we can take this 2 to 2 both of the sides. So this will become minus 1 minus 2 less than x plus 3 less than 1 minus 2. Otherwise you can take this plus 5 to the both side, and again you can minus with or subtract with the mean minus 3. So it will become again x plus 3. So for reducing that step, I have taken like this. Okay. Now we can divide this by sigma, so that this will be standardized. So which is equal to 1 minus probability of minus 1 minus 2 minus 3 less than x plus 3 less than 1 minus 2 is minus 1. That is 1 minus probability of minus 3 by 2 less than, if you divide this by 2, this will be x minus mu by sigma. So this will become z less than minus 1 by 2. Okay. Now what is our area? I am drawing here. Okay. Our area will be minus 3 by 2 to minus 1 by 2. So if this is minus 3 by 2, what is minus 3 by 2? Minus 1.5. And minus 1 by 2 is minus 0.5. Minus 0.5. So we have to find this area. So instead of finding this area, we can find what? 1.5 to 0.5. Sorry, 0.5 to 1.5. This probability, because normal distribution is symmetric. So area from minus 1.5 to minus 0.5 and 0.5 to 1.5 are the same. And how we can find this area? From 0 to 1.5 we will get the probability from the table, and from 0 to 0.5 also we will get the probability. So probability from 0 to 1.5 minus probability from 0 to 0.5. Okay, so which is equal to 1 minus, what is the probability from 0 to 1.5? So 0 to 1.5 is 0.4332. So we can substitute that 0.4332 minus, now we have to find probability from 0 to 0.5. So 0 to 0.5 is 0.1915. 0.1915. So after simplification we will get the answer as 0.7583. Okay, this is the answer. So in the next video I will explain how we can find areas of standard normal curve, that is area under the standard normal curve, by using calculator.